not be inside the meeting, but through the mobile
So
app.
all my multiple personalities could not join the meeting at the same time. Okay. Okay, complete.
Lo so, gliel'ho appena detto.
Share preloaded slides, share. Okay, beautiful.
Okay?
Yeah.
So what I was saying is that in case of troubles, just write Meet Echo on the chat, and some of
Gotcha.
us will.
Justin, we'll solve all problems.
Meta coordinates for you.
Что?
Meta coordinates. Talk to David.
Say it again. Sit down.
Talk to David about the bot.
Ah. Okay.
I will not partake because it will be.
Okay.
Shall we start?
Shall we start? Hello.
Do we have the mic on?
Yes, quite sure we have mic on. Ah. Good afternoon. Announcement which is not on the slides. When you scan the QR code, use one which is on the screen and not try to use the paper one because it didn't work for me. I'm not sure if it still works. Maybe it works actually. This is PANRG. So I hope everyone is in the right room. Finally, we're here in person. I'm very excited. This is Note well. Please read it if you have not seen it before. It's IETF specific Note well, which lists everything you need to know. And it also reminds you to be polite and be nice to other people as much as you can, and even better. Housekeeping. So yes, I say please scan QR code, which would allow you to join the microphone queue. So when you would like to ask a question, don't just run to the microphone, but press the button in your phone to join the queue. So we can have the common queue for both virtual and in-person participants. When you speak into the microphone, please say your name so we know who you are. For people who are not able to join us in person, who are remote, please keep your audio and video off unless you are speaking, and then you can join the queue if you'd like to ask a question, and then you can send. You probably should send audio, but you may send video as well. So, for speakers, if you are remote, please use share preloaded slides button in the Meet Echo and select your presentation and have control. Oh, yes, indeed. Usual thing, we need a minutes taker. I will allocate in the agenda 15 minutes to find a minutes taker next time, so we can get to our slot. Please.
Nobody make. Gori, can you, can I ask you to take minutes?
Gori, have you volunteered?
Gori Fairhurst will volunteer, and Gori Fairhurst will make an announcement that we need a minute taker for TSVWG tomorrow. But I'll take minutes now.
I would love to take minutes in TSVWG, but I'm flying out tonight.
Yeah, and I'm not there as well. I'm sorry.
Next time.
Next time. Okay, so thanks, Gori.
Oh, and also, Karsten will be helping you out in the.
Oh, beautiful.
Thank you,
Thank you very much. So, agenda for today. We have pretty busy agenda. Time permitting section where we have Spencer has been dropped, as Spencer just told me. Sorry, but I still hope to hear from you next time. So what's going on in this group? Since last IETF, we published another RFC. Congratulations, Brian.
Thank you.
We have, so now we have questions. We have things which we've done in the past wrong, thanks to Spencer summarizing them. And we have one active document, which is past properties, which we'll be discussing next, I guess. So, I guess it's the last slide. And,
I do want to say something about the last part.
oh yeah, please say something about the last part.
I see some faces in here who were in the Scion side meeting on, I guess that was Tuesday. There was a lot of discussion there about sort of how to take bits of Scion, some of which are sort of behind this path properties draft, some of which have been discussed here and there within PANRG, how best to bring that into the IETF and IETF. I think it makes sense to have a virtual interim between now and Philadelphia to dig into that question, right? Like, so we'd ask people from Scion and people with interest in this topic to get together at that virtual interim meeting, and it'll be a bit more of like a brainstorming thing than a let's look at presentation sort of thing. We will follow up on the list to figure out the right time to do this and like any suggestions that people might have with respect to the format of that. But I think there is an opportunity here to figure out which bits of that work belong in this research group and maybe provide that project with guidance for how to engage with parts of that within BOFs within the IETF as well. So yeah, we can take comments on that point. Spencer is in queue.
Yeah, Spencer Dawkins. I was just going to say, unless you can think of a good reason why this might be a bad idea, I would encourage you to go ahead and schedule it as early as possible so that some of us who haven't been paying as close attention have an opportunity to do more preparation work for it.
Yep.
Thank you so much.
Thank you.
Okay. So the next presentation is past properties draft. So yeah. Well, I am okay. What's
Can we not?
okay? Yeah, that's now should work.
Yes.
Grant preloaded slides. Oh,
Hello, Cyril. Can you hear us?
Hello. Yeah. Can you hear me as well?
We can. How's that? Is that okay for people in the back? Yeah. Say something else, Cyril.
Hello. Hello. Test. Test.
Okay, good.
Perfect. I'm not sure yet. I see the slides.
I think I gave you.
Yeah, you have to do the. What is it?
Well, I gave you. Okay. Let
But I
me
still see
see.
yours there.
Sorry,
Like
yeah,
what's going
sorry.
on.
My fault. My fault. My brain is. Oh wait, I share. Yeah, sorry. My brain is not working as you might. I said share preloaded slides. Hold on. Sorry. Okay.
You have to
Share.
stop sharing your slides first.
Yeah, it's what
You
I.
gotta go back over to.
Yeah.
Have you not done that?
I think I've done that. That's my problem. Okay. So what I'm doing wrong? Try this. Share preloaded slides.
Where are the preloaded slides coming from?
Here?
Are you sure you're not logged in twice?
No, I can be logged twice. I tried. It's not possible.
Okay.
Okay, let's do this.
Okay.
Oh.
Yeah.
Oh my God.
Yeah, there we go.
Share, and now I'm giving.
Yes. Got it. Yep.
Oh.
Okay.
10 minutes later. Sorry. Okay, you should have control.
Yeah. Perfect. Okay. Yeah. So today I'll give you a quick update on the path property draft. Sorry, my voice is a bit And so, well, I'm a bit a sore throat, but I think I should manage the 10-15 minutes. Yeah, I will try to keep the presentation short, so we have some time for feedback. So the biggest change we did since the last version is that we replaced host with endpoint. So we removed the standalone definition of host we had before, and we now have a new definition of an endpoint, which is defined as the first or last node on a path. And I think one thing that's interesting to note here is that actually in the beginning, we had already the term endpoint in our draft. This was when it was not an IRTF draft, but a draft of Reese. But we decided to go to use the term host because it was not clearly defined. But since the draft has seen a lot of change in the last few iterations, we think that now we can finally have this definition of endpoint, and it's also clear and correct. And of course, naturally, from this definition of an endpoint, we have the definition of an end-to-end path property, which is simply a path property defined on both endpoints and a virtual link between them, which is very useful since many concepts are defined using this end-to-end principle. And as a result of this, we replaced most occurrences of host in the draft with endpoint. I think we left one or two where we thought host is more appropriate, but most of them were changed. And then from the discussions we had previously, we felt that it was not clear enough why the definitions are context dependent. So we added some short text to section 2.1. And what we want to express there is that even a single path-aware technology might have different definitions, right? They might use these terms differently depending on the context. So one example I thought of is maybe a Scion where we have these path segments. So the routing only works on these path segments, but then for actual data traffic, data plane then works on combined data segments that are combined into paths. So there, the notion of a path will be different for one technology, depending if you look at the routing side or the data plane side. And then we added a new definition, which is a routing domain identifier. This was due to a discussion in the mailing list where this came up. And we defined a routing domain as follows. So path elements with the same routing identifier are in the same administrative domain, use a common routing protocol, and they communicate with each other using this specific protocol. And the classical example would be the AS number, and another example could maybe be an OSPF area identifier. And then we have a lot of minor changes. So we added the discussion venue section, which contains a link to the mailing list and a link to the GitHub repository where we have the draft and where we have issues where we discuss all the changes. And one thing that we realized when we updated the routing domain identifier was that the administrative domain property was kind of recursively defined, which is a bit weird. So we rephrased this to make it more natural. And then we extended the acknowledgement section. So that's already the end of my presentation. I think what I would like to hear most from you is your thoughts on this new endpoint definition, right? We already had endpoint before, we removed it in favor of host, and now we reintroduced it. So there I kind of have two questions. Do you think it's sufficient? So does our definition now cover all possible endpoints that you could think of? Or is there something that is not covered? And on the other hand, is it necessary? So is our definition too broad? Do we include entities that would not count as an endpoint, but they are still defined as an endpoint in our draft? So yeah, what do you think? How precise is our definition? And another thing that we would like to do is to fairly soon finalize the main definitions. And one thing that me and Reese thought when we discussed this is that once these main definitions are clear, are finalized, probably there will be very little thing left to do because the rest of the draft is essentially a non-exhaustive list of properties. So we could keep it open for a very long time, or we could just say this is the state now, what we think is useful, and the main definition will not change. So we could would ask for a last call. Yeah, that's all it from my side. I'm open for questions and comments on these changes.
Anyone in the queue for questions, comments, etc. on the endpoint definition? I will put myself in. Hi, Cyril. Brian, Trammell, Google, as an individual. I quite like the endpoint definition. I think it's sufficient in that I can't think of a thing that I would think might be an endpoint in a path-aware network that is not covered by it. But I mean, it's just basically, yeah, it's a node at the end of a path, right? It's a pretty good, and then node is also properly defined. Is it necessary? I think that the fact that we're having this discussion is the indication that it's necessary, right? Like if we don't have a definition for endpoint, people are going to ask where it is, right? Yes, I think both of the conditions hold. So thank you very much for your patience, yours and Reese's patience with going back and forth on this. This is hard stuff to pin down. I will reserve comment on ready for last call and let other people maybe talk about it. Or maybe we should just do a raise of like a show of hands poll for that.
Yeah, I guess we can discuss last call on the list.
Do we want to do a quick show of hands here?
Yeah.
Do you want to do it or should I do it? Let's figure out how this tool works. I think it's like right there, right? Show of hands.
Oh, show hands tool. Okay. If you know how it works.
I think so.
And I will remove you from the queue.
So, starting a session. Raise hand means yes, I believe path properties is ready for last call. Do not raise hand is no, I think we need to talk about something before we are ready to last call this document. Leave this open for it's like we're at 8 to 2. Would anyone who did not raise their hand like to put themselves in queue and let us know what we think is missing? Get more. No one. All right, we'll go ahead and close that off. I think we have pretty good signal there, but I'd like to know what's missing for people who did not raise their hands.
Just Brian, you might want to ask how many people have read a recent version, because that might also help you figure things out.
Yes, good point.
Yeah, because this change or definition of endpoint is really recent. This is from this latest draft. So I think there might be some people that do not agree with it, especially this part.
It's also nice and short, so people can probably read it right now while they're considering whether or not they want to get in the queue.
Yeah, it is text-wise, it's very little change.
Spencer Dawkins, one of the reasons I did not raise my hand was because I was still trying to figure out where the tab was, where I could click on it. And I mean, I was doing email and stuff. So please +1 to whatever you got. Thank you.
Andrew.
Yes, can you hear? So the routing domain, the ID, just defined here. Well, in my opinion, it might be a little bit ambiguous for something like, for example, in the routing protocol IS, it does use the domain for some purpose. So I'm not sure if you define this as a generic term, will that conflict cause some ambiguity with some specific routing protocols? Yeah, like as the domain does have its own meaning. So thank you.
Yeah, I would like the things we define, especially for example, this routing domain identifier is just kind of a generic identifier, right? Definitely, this needs to be defined in specific when you talk about one specific routing protocol like BGP, Scion, or whatever. So this is more like to give an idea what could be useful, right? And we think a way to group nodes based on their kind of ownership in a way, their administrative domain, and that they can communicate with other is useful. And that's why we added this path property.
Okay. Yeah. Okay. Yeah. Thank you. Just like to share my opinion about your generic term or some specific term. So thank you.
So I think I'd actually go back and ask Gory's question now real quick, just to get one more bit of data. So I'm going to ask for another show of hands as for who has read the path properties draft. Roughly as many people have read it as think it's ready for last call, so that's cool. Max has joined the queue. Oh. You were trying to raise a hand. Okay, got it. Okay, I think that's
Okay, I think my laptop is
okay. I'm gonna drive because your laptop
yes,
is now
my
done.
laptop.
Okay, good.
Not good.
So
If
of the 19 of you, please consider reading the draft. It's quite short. You know, speaking as an individual, very entertaining.
yeah, and so the next talk is about service awareness
Yes.
versus path awareness. So you need to share it.
I need to share preloaded slides.
Yes, and it should be this one.
This one.
Share and
And then I need to go to presentation view. Okay, and I will drive, so just say next slide. Find a microphone. Right here. Stand at the pink box. Stand at the virtual pink box.
Yes, and the pink box, what?
There is no pink box.
imaginary pink box.
Yeah,
Imaginary
where is
pink
that? All over the
I
place.
think it probably here is a camp because I
Yeah,
think
like right here.
In the middle of the
It's
line
okay,
where I go blind.
All right.
Okay.
Yeah, there we go. Right there. Yes.
Okay. Okay, then I can leave it up there and speak from here. Right. This title, adjusted to the context of this group, is about how to use proxies and a new way of a suggestion on how we could maybe do it. Please, next slide. Okay, so the problem that this is about is that performance enhancing proxies have existed for a long time. People hate them. They try to help out in TCP. And in fact, you know, because, well, they sometimes do something useful, right? They have good intentions, well intended, but you know, terrible outcomes of ossification, of playing tricks to TCP that they have to do, and this is why we all hate them. So Quick has started encrypting the header, large part of it, which makes it impossible to introduce ossification and also makes it impossible to help the transfer in the network, which has the outcome that people are now making presentations about how Quick does not work as well as TCP over a satellite link. I'm guessing, I don't know if anybody's tried Quick over millimeter wave, but I'm guessing it just won't work. So whenever you have anything, you know, in the network that requires special attention, where you're actually happy to have a proxy, that is a no-go. And so this is my effort to retrofit, and this is probably where you want to throw stuff at me. Retrofit proxies into Quick. Now, okay, first of all, I claim that the ossification problem is probably at least partially due to the fact that these proxies are transparent, right? By their nature, they have to lie to TCP, they cheat, they do things that are not supposed to be happening, and that's why they make assumptions about the header that are not supposed to be made. And that's how we cannot upgrade the protocol properly. using a proxy that is authenticated, known, signaled to, things could be done differently in principle. Mask is a candidate for that. Thinking about whether it would be a good idea of adding PEP functions there, I guess some people might think yes, some people might think no. There is an obvious issue here that if we start adding a specific function, then we build a reliance on that function in the network, and not everybody may be happy with the outcomes of that. We may reintroduce ossification if we don't do it right. If we get it right, maybe that could work. Here's another proposal. Next slide. What we suggest is to do this differently using separation of concerns. The idea is to use a separate protocol that we call Sidecar, strictly meant only for non-critical PEP functions. You would never rely on it for anything. You wouldn't rely on this being, giving you reliability in the data transfer, for example. But it's like an opt-in performance improvement. It's hard to breathe while I speak here. Okay. Yes, and the non-criticality of that thing is ensured by letting the main protocol explicitly opt in, choose the service via an interface, and that interface, at least the way we think about it, is that this interface would be on a local host only. So on the host, you would, for instance, talk to a library that supports that over an API, and that library offers a service, and you take it or you don't for a specific connection, right? And you may expect that this comes with a certain, compromising anonymity, for example, when you know that there are acts in place, but that's part of the contract. So you deal with it or not, depending on what the transfer is. A plan is to minimize changes to the main protocols, to the main protocol. You couldn't really help Quick much without changing it at all, but the idea is to make it as minimal as we possibly can. And if we get this right, then ossifying the sidecar would mean that the performance improvement doesn't improve per se, which is bad, but nothing really severe happens. You will never rely on that for anything critical. And the functionality of the PEP, they are the use case of these sidecar protocols. It's about providing a framework that helps with these kinds of things. Next slide. Okay, so in terms of functionality, what this protocol can do, right? On the data plane, what we can do is we can try to directly affect the main protocol in some way. There's not so much, really. We can try and manipulate the queue, just like a router does, doing queue management, draining the queue at a certain speed, something like that. We can maybe retransmit packets, but we would not pass the header because, well, it's mainly about Quick. The idea is to do this in a way that could work for TCP, for SCTP, for anything. But we don't want to rely on that. On the control plane, we would have this local on-the-host communication exchange with the main protocol. And the sidecar, of course, needs X, because this is about proxies, right? So you have a proxy that needs to X something, or maybe a receiver that needs to X something to the proxy. And the idea is that these X will be done using hashes over the transport header. Now, we don't even know how big that header is, but could be a simple rule like saying, let's say, take 20 bytes starting from the IP header, from after the IP header, or 30 bytes if that's not good enough, right? It's about avoiding that hashes collide and hoping that hashes are different between different packets. The X could be separate X. They could be piggybacked, for instance, using UDP options. That seems like a nice vehicle to me because Quick wouldn't even notice, right? Get stripped away if nobody doesn't want them. And well, I'm coming to two example use cases that illustrate how that thing could operate. And then we'll see what you think about it. This is about Quick, but you could think about TCP, SCTP, anything. The idea is that this would work independent of the protocol. Next. Okay. So the first example is you're trying to communicate over, let's call it a millimeter wave link, right? You have a link with fluctuating capacity between what here I call the sidecar proxy and the client. You have a normal quick data transfer. It's not interrupted. I'm just showing a queue. So it's like a router queue. It's a queue, it goes in. And you have X going back. And so we need to add something, to make it work better. Next, please. Begins with the entity on the server side, where you have a service choice. And this service choice here would be, well, if you tell me to increase my congestion window, I will. Right? So this is something that if you perceive it as a danger, if you think this sidecar thing is too fishy, could be used for denial of service attacks or whatever, you don't use it. If you're willing to use it, if you're willing to do that experiment, right, you pick that service. Next, please. And then what will happen is that on the proxy, the sidecar instance, it will take a hash of the packets. You use the hash to ACK back to the sender side sidecar instance. And using these ACKs, it will be able to get a bit more data towards the sidecar proxy, such that if you implement a different kind of congestion control, you have data available, which is what you normally get if you implement a TCP connection splitter, right? You would ACK earlier, and then when capacity becomes available, you have the data there. And in terms of the sending rate, that would just influence the draining rate of the router. That is something any device can do. We can't prevent routers or any devices from doing this. Since this is a congestion control, it would require a control loop. So the sidecar in this case will also have to be on the client side to produce X just to the sidecar. So that's independent of Quick. It's just looking at the hashes and producing X. And the notification to the Quick entity will be that an ACK has arrived, increase your congestion window, right? So that's the deal. You like it or you don't, you take it or you don't. Next, please. The minimal changes to Quick that you would need in this case, they're only on the server side. It's local interface communication, and if indeed you choose the service, then you would have to increase the congestion window when the sidecar tells you to. It's one case. I have another one. Next slide, please. This is something different, just to illustrate that the idea is to be really flexible and do basically whatever PEPs normally do. There is this paper that some colleagues from Trento University have done a long time ago. This was work on TCP. It's tricks playing tricks to TCP. The idea is that on a Wi-Fi network, any ACK that a client produces is really 2X, right? You have a link layer ACK and you have a transport layer ACK. And then that transport layer ACK probably produces another link layer ACK. So it's so much traffic just for one ACK. Now, rather than having all these ACKs, you could decide that the client doesn't need to ACK anything. And on the Wi-Fi access point, you can just take a look at the packets as they arrive. Remember, I forwarded this particular packet to the client and wait for the link layer ACK that comes back. And when that link layer comes back, link layer ACK arrives, I can associate it with the TCP header that I've just been forwarding, and I can produce the ACK on behalf of the client. Now, really, you wouldn't want to do this for all ACKs, right? You still want to have duplex, you still want to have options, but you could significantly reduce the number of ACKs that are necessary, which would save energy for the device, it would avoid collisions. And the idea here is to show how could we play that trick with Quick, for example. Next, please. So here the service will be, I will treat your sidecar X like client X. Basically, I accept them. Except that I said that we don't want to do anything really critical on this basis. So the sender would keep the data in the send buffer just in case until the client cumulatively acts them. But other than that, you know, proceed like normal when you get these ACKs. Next, please. The sidecar notification will be an ACK has arrived. It's a very simple thing, right? It does a hash of the packet and ACKs and says, okay, this packet I'm now ACKing. And as you can see, in this case, you don't need to do anything on the client side for the sidecar. But of course, the client would have to ACK less. So next, please. The next one is just saying that, well, the minimal changes to Quick in this case would have to be that you have to signal to the client that it shouldn't be ACKing as much over Quick, probably. And if you choose the service, well, that and also accept these sidecar ACKs. Again, right, it may depend. I may not at all want that to happen when I'm talking to my bank. But there may be so many things that I run over Quick where I really don't care about anonymity or things like that, where maybe this is okay. It's just an example. Well, two very different things that could be done, but the idea is you could do any PEP function. Next. It's already the last one. So what we believe is that this is a possible way forward to solve that dilemma that we now have between end-to-end encryption, ossification, and not being able to do any PEP functions. it will require a lot of research, right? We need to consider how to limit the overhead regarding X and hashing. There are several interesting things here, like how would you make a cumulative ACK when you have a hash? There are ways, we believe. There are many details here. You know, if you consider the use cases, for example, right? Let's take the link-specific congestion control thing. In case of TCP, because the PEP is invisible and transparent, it can just answer back to the sender. There's no need to even authenticate. There's no need to even find it, right? Because it's on the path and it answers to the correct IP address. In this case, it would have to be found. Now, and there will be a notion of trust, right? So the Sidecar proxy, in principle, just to give you a hint of what kind of steps would need to be taken. The Sidecar proxy, in principle, it can just send Sidecar X towards the sender. Could start with one, see if a device is there answering that, yes, there is a Sidecar entity on the sender side. But it doesn't really need to trust anybody. It's just producing the hashes and hacking. The sender side Sidecar, that would need to trust the proxy, right? Well, otherwise I'm giving false information. Then again, it's not easy necessarily for the proxy to be able to guess the hashes. That puts some weight on the hash function. If a path changes, well, there can be different Sidecar proxies. They would just all start to act towards me. Then again, if that is how we operate it, then we could have a string of multiple of these proxies answering without knowing about each other, right? So there would have to be some kind of negotiation phase to agree that this is the Sidecar proxy I'm talking to. So, there are open things. That's all I'm trying to say. It's also not so clear if this can be really done independent of the main protocol, but I think it's an interesting direction to take. And yeah, I'm very curious what you think. That was it. I think the next one just says questions.
Okay, and I guess we slightly over time, so we might have time for one quick question, and we probably should discuss it on the list. So, anyone? Oh, I said, close the queue.
We're faster than you think. I'll get out.
Yeah, let's try to keep it to like 30
Sure.
seconds.
Yeah, I'll be very quick. So yeah, I like the idea. Because I'd like to ensure, PEPs are a way of ensuring that we get the maximum utilization of the available bandwidth. So I like the concept of trying to do both, have the PEP and avoid ossification. So it's good work. I'd like to see more. So thumbs up.
Okay.
Jake.
Hi, do you have thoughts on how the PEPs would be discovered?
Ideas on how to discover the PEPs in this case? How do you know that there's one on path?
Yeah, so I mean, you could
Maybe
have
that's
all kinds
another
of ways
talk.
of doing it. I mean, like I have it here, right? There could be a simple way to do it. I mean, just one of them could just start hacking, sending one
But they'd
ACK
start
back,
hacking.
and then if you get that on the sender side, you would see, okay, there is one hacking. I negotiate that you're the one, and you keep helping me.
see.
This is not a fantastic idea, right? But it's one way. Kind of variations of that.
Okay. Maybe I'd love to see some ideas on that concept on the list a little bit. Maybe I'll think about it. But you think they would just act anybody who's sending regardless
Yeah, why not?
once and see if they get
Just
any
randomly
answer?
start with an ACK and say, okay, I'm getting one, so it means that there is somebody, and I'm answering back. Maybe I could pick one of them. There were these things in multicast where you were able to pick out of many possible receivers hacking back. You say, this is the one that's hacking for me.
Yeah, I'll think about that. Okay,
many
thanks.
strategies
like
possible.
There's like interest to continue this discussion. Like this seems like a potentially solvable problem and a good way to get there. Like discovery is hard anyway, but yes, I'm sorry to cut you off. Jim,
Yeah, it's fine.
I don't want to design the discovery protocol right here. I want to
Not today.
Not today.
No.
Maybe next meeting we can spend a little bit more time on this. Yeah. So Marcus, real quick.
All right. Yeah, I just want to say real quick. I think this is great work. We're actually in Ericsson we have been working on something very similar. We call it lightweight PEP and the multi-domain congestion control. It has a lot of these ideas in there, so it would be really nice to get in touch and sort of yeah, maybe discuss this more offline. We have a bunch of papers published on this. And we've also done simulations with the millimeter wave and such. So,
Send me an email.
yep, we do.
Thank you.
Cool. Thank you very much.
Thank you very much.
So, Berta. Next, so it should be.
We'll remove all that. Stop slide share.
Yeah,
Start slide share.
Yeah, so it should
This
be wider.
This one.
Yes.
Yes.
Sure.
Okay, so hi, my name is Berta Serracanto, and I'm a PhD student at UPC, and I'm going to be talking about wide area networks for cloud autoscaling. And yeah, next slide, please. So I'll go quick over the agenda. First, I'll talk about the scenario that I'm presenting and exactly what is network autoscaling. Then I'll go over about how we put the pieces together for prototyping, and finally some plots about the results that we got from it. Next slide, please. Okay, so if we focus first, this is the scenario, which is built of 3 different parts. The first one, let's say it's a branch where all the users are connected. The second one would be the cloud, where there's the application that these users consume and its cloud orchestrator. And the third one would be the software-defined network, which is the part that brings together the users and the application and provides some connectivity. So if we now look at the situation when an application deployed at the cloud suddenly receives an increase of requests, what the cloud does is autoscale and provide more resources to that application. And it does so in 2 different ways. The first one being horizontal autoscaling, which is deploying more replicas of that specific application, so the load can be balanced and managed more efficiently. And the second one is vertical autoscaling, which is incrementing the resources on replicas that are already deployed, such as increasing the CPU or more RAM. So if we now take a step back and look at the big picture again, there's, okay, the situation, there's an increase of load. The cloud has done something about it, but there's the problem that the network has not been modified and it might become the bottleneck. So that's when translating this autoscaling term to the network makes sense. So we define horizontal network autoscaling, which is changing the overlay path, and vertical network autoscaling, which is changing the characteristics of the underlay path. So next slide, please. Oh, that's the last one.
That's the next one.
Yeah, thank you. So if we go over first the horizontal network autoscaling case, as I said, imagine that you have this traffic that's usually routed through the standard path, and then suddenly there's the increase of load, and then there's a way that the application is able to tell the network, hey, I'm autoscaling, I will need more resources because they are coming, or this channel that you have is not going to be able to meet my demands. So then here's where the SDN controller can have a policy that defines, okay, now that we've seen that that's the case, you need to be routed through this other path. And in terms of vertical network autoscaling, it's a similar case. In the same scenario, there's a cloud autoscaling event, and then the network reacts to it by adapting. And in this case, if there's only one connection, vertical network autoscaling would mean adding more bandwidth if it's needed to. And then it's an elastic thing. It can go back when there's no more demand of that bandwidth. So yeah, I think a couple of slides. You can go over the next one. So here's the prototyping. You can see that both the users and the application have been deployed in public cloud. And what's interesting about here is if you look at the purple boxes, it's the way how the application communicates its requirements to the network. So there's the CN1 operator, which let's call it a plugin on the Kubernetes orchestrator that monitors the application and what's happening on there, if there are more replicas or if these replicas are increasing. So monitoring the cloud autoscaling events that are happening. And it publishes these changes to the service, an external service registry, which is then continuously pulled by the CN1 reader, which takes into account and says, oh, there's been a change, and notifies the adapter, which is the piece that's in charge of talking to the SD1 controller and the underlay, saying, okay, network, you need to do something about it. And that's when the changes come in. So, yeah. Yeah, that's just a quick plot about the network, horizontal network autoscaling performance, where we switch the traffic over both paths in a rate limited one and a 1 gigabit per second tunnel. And as you can see here, it is obvious when there's traffic in one path, there's not on the other one. And we found that the delay obtained was not impactful, so the change of routing was successful. And this one, please. And on the case of vertical network autoscaling, if you see the orange line, it's where the cloud orchestrator says, okay, there's a number of replicas that is increasing. And if you look at the green line, it says it's the network autoscaling at the same time, when proactively, meaning that, okay, the cloud has had an autoscaling event, and now the network has one too, to go matching, because then in the blue line comes the traffic increase. And since the network has proactively adapted to that, it's now able to take into account and don't have any problems. And yeah, next one. And that's all. For more details in the implementation or more specific results, you can check out the paper, or if you have any questions or comments, just go ahead. Thank you.
Thank you very much. We have time for probably one quick question.
Okay.
Someone would like to go on? Going once, going twice. Thank you very much.
Okay,
Very
thank you.
cool stuff. Next, all right.
And
So
next, Polka source routing info.
yes. Yeah, go quickly. Yes. Yeah.
Hello, my name is Rafael. So I'm here to present our solution Polka, that is a polynomial key-based architecture for SAS routing. So next, please. So we are trying to connect what Peng's problem solve, PANRG's problem solve in Polka. So we have known that endpoints have little information about the path over which their traffic is carried. So and no contract beyond the destination address. So next, please. So taking care about what SDN table-based solution. So we have some, next, please. Yes, the SDN table-based solution approach suffers with the path setup may involve several state configuration. So once we have, for example, SDN table-based, we are suffering with this kind of every time we need to keep states along the path. So it deals for us a specific question, how the SDN table-based solution offer path-aware control. And we have some problems about that. For example, large number of scale, that which means deal us for scalability, limit capacity of tables, granularity, and latency for path configuration. Next, please. So look at this concept. We are to just connect with this strict source routing. The strict source routing is a matter of just only changing the source path, so the edge core, the edge part. So we don't need to keep all the states in the infrastructure, only change in the edge. So next, please. So why you should use Polka as a strict source routing? Polka routing simultaneously meets some follow requirements. For example, topology agnostic. So we don't need table in the core, and we have fixed headers. And also we implement in program switches for a single path and multipath. So it enables a lot of applications in that case. For example, path expressiveness, reliability, and efficient in-band telemetry. So next, please. So
how Polka work. So we have three polynomials. We have a route ID, which identify and calculate via using CRTs, that's a Chinese remind theorem. We have a node ID that identify each core node for, so the node ID, we use a recursive polynomial, and for the port ID, we have identified the ports for each core node. So the forwarding uses a mod operation based on the reminder of division between the route ID and the node ID. Next, please. So just showing a timeline, in 2020, we got a paper published called Polka, and in 2021, we got a Google Research Scholar Award, and 2022, we got an Intel Connectivity Research Grant. And also, we recently published our paper, Bootpath Polka. Next, please. So how to implement Polka? Polka trying to reuse CRC hardware to offer polynomial model operation and extern in P4 languages. So, for example, some the Tofino switch supports this is kind of extern that will offer us to calculate the model operation in a polynomial way. So the RAE project is an open source full features router on which we have network hardware for research and education. So the data plane that's supported now is BM2 and Tofino and DPDK. Okay. So the control plane free routers use also standard distributed protocols and state and maps segmented routing index into the node IDs. So you can get available topologies from a leak state protocols. Next, please. So showing just a small example of how it works. So for example, we have a set of switches. We have switch 1, switch 2, and switch 3. And we have this polynomial for each switch that we have. This is like a radiative polynomial. And we have output port as a polynomial as well.
So can you, we're at like 7 minutes of 5. Can you
wrap
up, please?
Just the last one. So, and go ahead. So you have the route ID. And basically, on each switch, you calculate the mod operation by the remainder of the division between node ID and port ID, node ID and the route ID, and you get the output port as in the final. So next, please, go ahead. So in the end, you just you pack deliver the application in a transparent manner for the destination, removing the route ID in the package. Next, yes, thank you.
Thank you very much. Thanks for speeding up. Have a look at the slides. We went a little bit quickly through the last bits of how that goes on in each stage. And okay. Raphael, you're around for today and tomorrow,
I'll
correct?
be around today and tomorrow.
Yes, cool. If you have questions, please find Raphael. Sorry, we need to go to the next, which is Luis, correct? No. Luis is in queue. No, okay.
Yes, I think we have one more talk.
Great. Luis, can you ask your question in like 30 seconds? Oh, Luis is there. Cool.
Hello, Luis Contreras from Telefónica. I would like to ask how the protection is implemented in this schema. So do you need to pre-calculate the protection beforehand? And so
we are able to encode multiple paths and the same encoding route ID. So once this packet achieves, for example, you have some fail in one path, when you go to another path, URL encode that switch needs to go to that port. So you can have multiple paths in the same encoded route ID, which means if this not independently, one switch that another switch, the result of them, because they are calculated independently. So that's why we can encode everything together in the same route ID in this case.
Okay, thank you.
Sorry.
Thanks a lot. Zong Peng, I think you are remote. Can you go ahead and?
Yeah. Okay.
Can you hear me? I'm Zongmu from China. Thank you. I'm Zongmu from China Mobile, and this is version 1 of the draft. It's about gateway-based trust relationship between the endpoint and the intermediate node. We have received some comment, and we wish many thanks for that, and we wish more comment about that. Next page, please. I can control it.
Yes. Yep.
our target is that we think that the BNG working as the gateway or the endpoint is able to maintain a per connection state and a trust relationship for each user. So based on this gateway or this BNG, we want to make the endpoint trust the information from the ingress P specific intermediate node. We think this ingress PE can make some decision for the path to the egress PE, so it will influence the path of the client. And the ingress PE can trust the suggestion from a user. A user, for example, is the endpoint is the client. If the client sends some suggestion for some information to the ingress PE, the ingress PE can trust them. And next page. Initial mechanism we thought is that is from this ingress PE to the client. For example, the ingress PE need to send some message to the client. It can, for example, make a signature for the message by using a private key, so that if the client receive it, it can check it use the public key or the ingress PE. If the information is from the client to the ingress PE, we think that the BNG can make a signature instead of the client by using a private key belonging to this BNG. Or if the BNG between the BNG and the ingress PE there is a IPsec tunnel, it can send the traffic of the client into this IPsec channel so that the ingress PE can trust that the BNG have checked that is a valid user and the information is have been verified by the BNG. So we think that if we have this gateway, we can make it easier to have a trust relationship between this client and the ingress PE. And then thanks for listening and welcome for comments. Thank you.
Perfect. And we have like 3 minutes for questions, I guess.
Questions?
Luis?
Luis, you're still in from last time? Yep.
No questions.
No questions.
So great, so we're on time.
Thank you all very much. So we are still working on the logistics of the interim meeting on Scion engagement. Expect announcements to the list shortly, but this will be between now and Philadelphia. I suspect, given sort of like the engagement and all of the really sort of like interesting talks in the area that we've had this time, that we will also have a meeting in Philadelphia, a hybrid meeting in Philadelphia. And it was great to see you all. Thank you all for all of the talks and the discussion. It sounds like, looking in the chat, it looks like sort of Michael's thing is halfway to being designed, group designed by people in the chat. So we look forward to some discussion of that on the list and to seeing how that develops at the next meeting as well. Thank you all very much and have a great rest of your IETF.
Thank you, Brian. Sorry, this piece of crap. They ignored me. They just like today the ticket was there, we stay tuned. So it's like, look, if I keep it 10 minutes, it's like recorded. So you just need to like, no, well, yeah. Okay, so tonight, few minutes. Okay. His coordinates for what? I still because my brain was.
I'm telling them to do the proxies quickly. Especially here. Indeed. Signs are